Hello, this presentation presents our work on ultrasonic levitation using the silent Zynq platform and ultrasonic phase arrays. This is a collaboration project between two undergraduate students, Daniel and William, one MSc student, Brenda, with two supervisors, Asier and Jose. All work done at University of Bristol, UK. This slide shows the background of the ultrasonic levitation concept. Basically, an acoustic levitation employs an acoustic wave to suspend an object in air, and this is possible to achieve using an ultrasonic phase array. The array consists of a group of transducer elements that are pulsed independently, and by using the principle of phasing, so basically delaying how the transducers pulse at different times, a beam pattern is formed, and this focuses the sound in a desired direction called the focal point. Our objective basically is to exploit the FPGA resources in terms of hardware accelerations, ADC conversions, and high I/O pin count and hardware parallelisms, and basically to create a full system that can achieve ultrasonic phase array based levitation at low cost and high performance. The slide shows our SILE implementation based on Vivado, with the system on the left, the user interface, the P-mode hydro sensor used to correct some parameters, and one of the ultrasonic phase arrays we have developed at the university. The implementation is based on the combination of several projects done by the team itself. The ultrasonic phase array using the silent ZedBoard can either be a flat phase array shown on the right down, or can be an annular or in the sense of a semi-spherical shape shown on the right top. Both systems have been interfaced using Silence Vivado and SDX IDE for the ARM processor software. The processing system calculates the phase shift for each transducer, and it can do it either in software or with a hardware acceleration block. And the ultrasonic drivers generate the delay 40 kHz square wave signals for each transducer. There have been several interactions of the project. We have used different types of traps to increase the stability of the system. In this particular interaction, we are using a twin trap that is more stable than just a basic non-trap system, and allow us to remove the reflector plate and still achieve stability, levitation stability. So we don't need to use the standing wave approach and still be able to run the system efficiently. Our feedback path allows us to acquire echo waves, and two receivers detect the echoes on an ADC module, and this can be used to estimate levitation and the presence of objects. In these results, we see a levitation of a small polystyrene ball. We have the ZedBoard and the ultrasonic phase array. We also see a mesh we use to basically initiate levitation by positioning the particles in the right place. And also we've been, with this cardboard material, we've been able to detect the presence of objects and then make the ball react to the presence of objects, basically creating the feedback loop. In this slide, we see a movie that shows levitation on the XY plane. In this movie, we can see the object controlling the ball following a circular pattern at certain speed. Here we can see our ultra phase array menu, the different options available, and also how these are used to control and detect and react to the positions of certain objects. In here we can see the different options we have in the phase array menu to perform different sort of movements and control, moving the bolt in different directions. Here we can see the links to some YouTube videos that also show in more detail the different type of control we've been doing, and also the GitHub link to the materials of this project. And finally, as conclusions, object levitation have been achieved using an FPGA-based ultrasonic phase array. The levitation is affected by shape and size, and also by the temperature and humidity, and we use the PMOD hydro module to correct those. Future work, we are looking at system identification of the phase array with object levitations and design of a PID controller to improve the feedback loop path. Also improvement of the phase array using more transducers and smaller transducers for greater accuracy and control. And basically increase the capabilities of the phase array by levitating objects in a 3D space.